All right, guys. Good morning. I wanted to. Ooh, look at this. Braided my hair and now it's all frizzy. Okay, so I wanted to take a moment and just share a little bit about my heart with you. I think I've always kind of been more of that kind of a teacher than just all math all the time, right? So anyways, I just wanted to encourage you guys to continue learning. Okay. I know it's difficult. Like, I love teaching. I love my job. I love being there with students during class, during tutoring hours, and really explaining things. I love to explain stuff. I've always been a talker. I've always been like that. So I get that it's difficult. I really do. But I would love for you guys to have an appreciation for learning. Okay? It's difficult. I think I found my appreciation for learning when I went back into when I went back to school for my master's. Because it was really my choice, right? One, I wanted to make more money, but it was my choice to go back to school, and it was difficult because I was working, so I had full-time teaching job where you have to do your planning, your teaching, your grading, and then in addition to that, I was planning a wedding, so that was chaos. And so I had all of this stuff going on, and yet I really enjoyed what I was learning, and I enjoyed the process of learning things and just having new perspective on stuff and all that stuff. So that's kind of where I think I realized how much I actually like to learn and how I like to it might be a little like, I really like to feel smart. I like to feel like I actually know stuff. So that all added to it. But I just want to encourage you guys to to try to learn, to try to exercise your brain, to build your knowledge, to have a deeper understanding of math. You guys are one of the few that are in upper level math class, you know? And so I just want to encourage you guys that even though I know it's difficult, keep trying, okay? Watch the videos, press pause, practice, message me if you need to. I'll set up extra Zooms, like, to try to explain stuff to you. Whatever. You guys let me know, okay? But I want to encourage you guys to really try to continue pursuing the knowledge and your education and stuff like that. Because I miss you guys, and it makes me feel like there's this even bigger distance when I only see like 5 people turn in stuff. That made me like really sad. So, because that's my communication with you, you know, like we have Zoom. But when not everybody shows up there, it's like, okay, well, let me see what they've been doing for the week. And then when I don't see anything there, it's just, it was really discouraging as a teacher who loves to teach and who loves to hear and see her students. So anyway, so that's my little moment of encouragement. Okay. Now, I'm going to do a little, so you guys are going to do a warm up for me. I want you to try it. I have my answers worked out for it. So I'll write the answers. So I'll give you a second and then you can pause it to try it, and then I'll write the answers. And then if you would like to have a picture of my work, just message me on Remind and I can show you my work for it. Okay. So let's see, back to my little mini screen. Perfect. So I'll give you a second so you can pause the problems. Okay. And then, okay, so your answers are, where's my little ink? Purple today? Purple. So the answer to this first one is 65 over 4. The answer to the second one, I simplified it the most I could, so it could have been, I started with 4 plus 3 pi squared over 2, but then I combined those two fractions and I got 8 plus 3 pi squared all over 2. And then for the third one, okay, so for the third one, I got to e to the s, oops, sorry, I looked away, e to the s plus ln of s from -2 to -1. But when I plug in the negatives into the ln, I get error messages. So what I want you guys to do is take this and plug it into your Math 9. Okay. Maybe simplify it first, actually, because that's what I did when I was integrating. So take this divided by this, and this divided by this, and then plug that in using Math 9. And that'll be good. Okay. Okay, so we're in our last unit of applications of integrals. We're going to be looking at area. Okay, so our EQ is what does the definite integral represent. So today we're going to be looking at what's called area between two curves. So the definite integral is the area under our curve between A and B, right? And then it goes from the curve down to the x-axis, right? But today we want to look at how do I find the area between two curves. Okay, so what that looks like is this green space right here. Okay, so I have I wanted to find, or if I want to find the area of this green space, okay, based on what we've been doing before, we can look at it as the area of this top one, right? And then we can look at the area of, if I have this g of x, the definite integral would be the space below it to the x-axis. And so what would I have to do with yellow and blue to get this top function? You can see it, think about it. So what would I do with this, all of this area and this area to get the green area? Okay, I would subtract them. All right, so it says to find the area between two curves, f of x and g of x, evaluate the antiderivative of the difference of the two functions from a to b. Note the function on top of the region is always f of x, meaning it's the one that's going to go first. Okay, so you're always going to take that top one minus the bottom one. So yeah, so area equals the integral from a to b of f of x minus the g of x function. And then we'll take the antiderivative with respect to x. Okay. So make sure you pause, write stuff down. This is actually super important. I would write all of this down. Okay, so here's an example. Two functions that do not intersect. All right. So I would give you this information. So it says find the area of the region bounded by y equals x squared plus 2, y equals negative x equals 0, and x equals 1. So when you draw them, x squared plus 2 is a parabola shifted up 2. Y equals negative x is a slope line with a slope of negative 1. Hold on, I have to sneeze. Sorry, I probably could have paused it. Okay, so, and then x equals 0 is a vertical line, at 0, and then x equals 1 is a vertical line at 1. And so what these two did was actually tell us our a and our b, okay? And then in the last slide, I said the f of x is always the top function. So your top function is this guy, right? So we're going to put that first. And then that means this other one, y equals negative x, is g of x. So from a to b, so from 0 to 1 of x squared plus 2, right? That's my f of x, minus g of x. It helps if you just put them in parentheses so that you can kind of make sure you subtract the right thing. Okay? And so we're going to work this out. So I would be going from 0 to 1 of, and then I'm going to simplify this. So negative x is a positive x, and then there's nothing I can combine, right? So I'm just going to put them in order. So x squared plus x plus 2 with respect to x. Okay, so once you actually do this minus this function, you combine it into a single function, and now it's just normal integration. So x cubed over 3 plus x squared over 2 plus 2x. And we're going to go from 1 and 0. So you plug in 1, you get 1/3 plus 1/2 plus 2 minus, so that's f of b, minus f of a. If I plugged in 0, each of them, 0, 0, 0. So minus 0. Okay, and that equals, let's see, I'm just going to do 1/3. I could do it as a fraction. That would probably make life easier, but oh well. Right now I have a calculator in front of me. So it would be about 2.83. Oops. Okay. Okay, so up next, we have when, so you have your two functions and you're looking for your area between the two curves. And then this time you see that you are given, so it says find the area of the region bounded by y equals x squared and the line y equals 2x plus 3. So you can tell that the blue is your parabola, y equals x squared, and the red is the line, so that's the 2x plus 3. Okay, and so when you're setting up your definite integral, these functions intersect in their 2 points, right? The last ones did not intersect. So I gave you, so these last functions did not intersect. So you were given this extra information where the x equals 0 and the x equals 1 to know your a and b. This time they are intersecting. So you can see the left point and the right endpoint of this region. Okay, so when we set this up, we can tell that this time the red is the top function, so f of x is going to be the line, and then the blue is the bottom, so g of x will be the parabola. And here at the very bottom down here, so this -1 to 3 came from graphically seeing from -1 is this x value to 3 is the x value that it ends at. Okay, so it went from -1 to 3. And then we took our top function, 2x plus 3, minus our bottom function. Okay, if you are not given a graph, you can find these algebraically. So if you are not given this graph to see and you haven't drawn it on a nice pretty graph paper where it's easy to see the points of intersection, you can take each function, so you know they intersect, right? So you can take each function and set them equal to each other, because where they intersect, that's where the two functions equal each other, right? So then you would solve this. So you move your 2x over, so minus 2x, you move the 3 over to the left with the x squared. So now you have a quadratic, and you can factor that. So x minus 3 times x plus 1, solve, and you get the intersections at x equals -1 and 3. And so that's how you can, that's how you can assess where they intersect. And so that's your A and your B from left to right. Okay, so let's actually do this one. So we had, let's do purple again, from -1 to 3 of f of x. So my top function was 2x plus 3. And then we're going to minus our bottom function. So if I put that in parentheses, minus my bottom function, which was just an x squared. And then we're taking the antiderivative with respect to x. So we simplify in here. So here I would distribute that negative. It's just to one number. So I'm going to put that x squared in the front. So I have negative x squared plus 2x plus 3. And then that's going to go from -1 to 3. Okay. And then, so now I just take my antiderivative like normal. Okay. So here, now it's -x cubed over 3 and plus 2x squared over 2. So the 2's will cancel and I'll be left with just x squared. Plus 3x, and then I'm going from -1 to 3. All right, and then since I don't have a calculator, so you guys should all have a calculator. Hopefully you can get some batteries, but I don't have a calculator, so I'm just going to do, I'm going to end it where, like, plugging it in. So I would do f of b minus f of a. So I have negative, and then 3 cubed is, so the 3 is in parentheses. So don't forget. So this would be 3 cubed, which is 27, then times the negative. So it's not -3 cubed. In this case, you would get the same answer, but if it was an even power, you don't want to mix up the positive and the negative. Okay. So I get negative 3 cubed over 3 plus 3 squared. Plus 3 times 3. Okay, so that's my f of b, plugged into 3 to each of those x's, minus plugging in the -1. So -1 cubed over 3 plus -1 squared plus 3 times -1. And actually this one's not too bad. So 3 cubed is 27. -27 divided by 3 would be -9. And then let's move this up. Plus 3 squared, which is 9. And then plus 3 times 3, which is 9. So those actually cancel. So I'm left with just a 9 from the left. And then on the right, minus, I have -1 cubed would be -1 times -1 is a positive. So minus 1/3. And then here, this is 1. And this is -3. So -3 plus 1, -3 plus 1 is -2. Okay, so distribute. So I actually have 9 plus 2 is 11 minus 1/3. So that's like 10.67. Sorry, I got all small, but yeah, so 10.67 is that. Or if you wanted to change it into fractions, you could do that. Okay, And our last one, finding the area between two curves when there are more than 2 points of intersection. So notice if I have this cubic function, that's the blue one, and then I have a parabola, negative x squared plus 2x, so a downward facing parabola, that's the red one. And so you'll see that you have 1, 2, 3 areas of intersection. So, all right, so that was actually like a 30-minute pause for me, so I don't remember where I left off. I do remember saying that, okay, maybe it was that with this one, so it says find the area between two curves when there are more than 2 points of intersection. So here we have 3 points of intersection, okay, which causes 2 different sections of area. So all we're going to do is, for this, we're going to take and, oh my gosh, sorry. We're just going to find the area of each section and then just add them together. Okay, so we're going to treat it like 2 separate problems. This one first, and then this one, and then we're going to add our 2 answers together to get our total area. Okay, so I'm going to start a new screen, so make sure you pause, draw this before moving on, okay? Okay, so I took a picture of it on my phone so that I can do this with you. So for the first section, we are going from in the x's, so we're looking at our a to b. So it goes from -2 to 0, right? So that first section goes from -2 to 0. And then also in that first section, the blue is on top and then the red is on the bottom of it. So we're going to take the blue function, which is 3x cubed minus x squared minus 10x. Okay, so we're going to take that blue function minus the red function, which is negative x squared. Oh, I did not take a good picture. Dang it. Hold on. I gotta go back. Oh, just plus 2x. Cool. Okay. So that's going to be my first section of area. Okay. And then the second section of area goes from 0 to 2, if I look closely. So it goes from 0 to 2. And then in the second section, the right-hand section of area, the red graph, the red function is now on top and the blue one is on the bottom. So I'm going to do that. So I'm going to make sure I do the red one first. So negative x squared plus 2x. And I'm going to minus the minus the blue function, which is now on the bottom. So minus 3x cubed minus x squared minus 10x. Okay, so we're going to do these one at a time. And then in the end, we're going to add our two answers. Okay. So, so for this first one, I'm going to combine these. So I'm going to take my, let's see, I'm going to take my little minus sign here and I'm going to distribute. Did not like that line. Okay, so I'm going to distribute the negative to both terms. And so when I do that, I get 3x cubed minus x squared minus 10x plus x squared minus 2x, right? And so my x squareds actually cancel out because I have a negative x squared and then a positive x squared. I don't know what's happening. Hold on. This did not happen earlier. try this again. So I'll go this direction. That helped. Okay, so this was a negative x squared. I erased that negative somehow, sorry. And then the positive x squared cancels out. And so I'm going to combine everything else that I have left. So I have 3x cubed. And I had a negative 10x and then a negative 2x. So I have a negative 12x. Okay, and then I'm going to go from negative 2 to 0. Okay, so now I need to get the antiderivative. So I'm going to have 3x to the 4th over 4. And then minus, I'll have 12x squared and then over 2. So 12 divided by 2 will be a 6. Okay. And then that is going to be from negative 2. Sorry, don't know where 1 came from. To 0. Okay, so now we do f of b minus f of a. So if I plug in a 0 and a 0, I would get 0. And then when I plug in negative 2, I get, so minus and 3 times negative 2 to the 4th power, all over 4, minus 6 times negative 2 squared. Oh, that's annoying. 16. So here I get 3 times 16 divided by 4 equals, so I get minus, and then 12 minus 6 times 4 is 24. Oops, 12. So I have negative 12, which is then positive 12 for that first curve, or that first area of space. And then for the second one, I do the same thing. So I'm going to distribute that negative. So I have negative x squared plus 2x, and then minus 3x cubed plus x squared plus 10x. And so my negative x squared cancels with my positive x squared. And then all together here, I have negative 3x cubed plus 12x. And this time I'm going from 0 to 2. And, okay, so now I need to integrate. So I have negative 3 times x to the 4th over 4, and plus 12x squared over 2, and then the 12 over 2 would be a plus 6x squared. And then I'm going from 0 to 2 this time. So plugging in a positive 2, I get negative 3 over 4 times 2 to the 4th plus 6 times 2 squared minus, and then when I plug in 0 and 0, I would get minus 0. Okay, so here I would get negative 12. Oh my goodness. Negative 12. Negative 12. Plus 24. And so I get a positive 12 for the second piece of area. And so then all together, the first area is 12, the second area is 12. So I have a total area of 24 for both of those sections. Okay. So that's that. It's a whole half an hour. Sorry. And then, so your practice for me for this is here. So these first two, and give you your two equations, and then I tell you x equals 0 and x equals 2. So those are your A to your B. So those are your cutoffs, the left cutoff and the right cutoff. Same thing here. You have y equals sine of x, y equals negative x. Those are your two cutoffs, x equals 0 and x equals pi. So from 0 to pi. Then in 3 and 4, I give you two equations. And so you can either graph them on your graphing calculator and visually see where they intersect, or you can use algebra and set this first one, so x squared plus 4x plus 4 equal to 4, set them equal to each other, and then solve for x, and that will get you the x values of your A and your B. Okay, same thing for number 4. And then number 5, it says to use Math 9. So once you have your function, you're going to want to plug it into Math 9. If you have any specific questions with your Math 9, some of you, when you push it, it'll be this beautiful integral and it'll be perfect. And then some of you, if it says FINT, it takes some specific steps. So if when you press Math 9, if you get FINT, maybe shoot me a message on Remind so I can walk you through what to push, okay? Or what to input, okay? So this is it for, I guess, the week, okay? Which means we will have to do 2 lessons for the next 2 weeks to be able to finish with what I want. So right now we're doing area, and I want to get through volume, and then that will be a successful second semester for us. Okay, so thanks for watching, thanks for working, practice these problems, and message me as you go. Okay, bye guys.